Okay, let's finish out section 1.5 and look at some word problems. So I think sometimes word problems cause a lot of anxiety, and what I like to encourage you to think of these as stories, as English, focus on the words first and kind of put the math aside. I kind of drew a little diagram down here to explain what I mean. So when you first approach a word problem, I think it really helps to just focus on the words. Just focus on what is the story, what's happening. So this is where you should start, is with the English. Just read it, understand what it's about. Some things that you can do in this first step. Okay, let's finish off this section by looking at some word problems. Now, I know word problems tend to cause anxiety for a lot of people. So if you're someone who, when you hear word problem, you get a little nervous, I just want to walk through some things that you can do to help you get from the word problem or the story and all the way back over to the answer. So what I suggest is that when you first start out, you only focus on the reading, focus on the English. So I kind of drew a diagram down here showing that you start with English. Okay, so don't worry about the numbers, don't worry about how you're going to get the answer. Don't worry about any of that at first. Just read the problem. You might have to read it a couple times and just picture what's happening. Do you understand where people are at? Do you understand what the objects are? What the action that's happening? Sometimes it helps to draw a picture or a diagram. Maybe list the things that you know. What are all the different facts? If there are any formulas that relate to it, write those down. We're going to talk about assigning variables to unknowns, and in this chapter, there's always only going to be one variable. Okay, as we move forward later in the year, we're going to have problems where we have more than one variable, but for these problems, just know that for chapter 1, you're going to have one variable, an x, or whatever letter you decide to use. Maybe even estimate the answer. So without even really thinking through the math, just think to yourself, about how big do I think it is? And that can kind of get you set on the right thing. So this is really focused first on understanding, focusing on the words, focusing on the picture, and kind of putting the math aside, not thinking about that for a minute. And I think if you take the time to do that, it will greatly improve how well you do on word problems. I think we get in a hurry. We want to jump in and get to that math and start working and plugging some numbers. But a lot of times we do the wrong things with the numbers if we don't understand the story. Okay, once you're pretty sure that you have a really good understanding of what the story is all about, then you're going to write an equation. Up here in step 1, you've probably defined a variable. So you're going to write an equation or an inequality that uses that variable and the rest of the information in the problem. So you don't start doing this until you understand the problem. Now this step 2 is where we are taking the English and we are converting it into math. So we're taking all of that information, writing it into an equation, and now we have math. So once you get to this point that you have an equation, now you need to take those words and put those aside and just treat this as if it's just a math problem. And recall the practice that you've done with just math problems. Don't let the words get in your way. So step 3 is to solve the math problem. And then you are going to check your answer just like we do for all of our other problems. We talked about that before. Plug it back in. And then before we get away from this problem, we're going to go back to the English. So this is step 5, going back to the English, and you're going to say what the answer to the question is. The reason that step 5 is so important is a lot of times we get done working the math problem, and let's say that we end up with x equals 2. We're ready to move on. But what if the question asks something else? Sometimes it asks for more than one thing. Another thing that, circling back to the English, is you might need to label your answer. Is it $2 or is it 2 miles? Or is it, two bricks. What is it that it's two of? And so you're going back to the English, read the problem again, make sure you've answered the question, and make sure that you have labeled it. And I don't worry too much about writing your answer in sentences. Now, if this was a real world problem, and for example, you were doing a study for your boss, or you were doing some calculations and you were taking those answers back to him, most likely you would put that into sentences. So that's why I put that there, because in the real world, when we answer questions, when we go back, we explain things and it's in sentences and paragraphs. Okay, so this is kind of what I want you to think about. Only focus on either English or math at a time. Don't try to do it all at once. And I think you're going to have a lot more success as you do word problems. So I thought the best way to move forward here is just to work a couple problems together. How's that sound? And I am just going to open up your homework set. So this is 1.5, and we're going to look at a couple problems. I'm going to start with number 15. So I'm going to pull this down here. Now, your number 15 may look just a little bit different, and that's okay. And I know this is kind of small on your screen probably. If your number 15 has different numbers, that's okay. It's probably going to be similar though. Let me see if I can blow this up. Okay, there we go. I think this will be a little easier to read. Question number 15 says the perimeter of a rectangle or rectangular field is 340 yards. The length is 70 yards longer than the width. Find the dimensions. And then we're going to work through this and then start filling in the answers. So I'm going to pull up some paper to work on. Okay, in the bottom half of the screen, I'll work the problem, and then you can still see the problem there at the top, I believe. Let me move this up a little bit more. Whoops, that didn't work. And here's my paper. Okay, so reading the question, it says the perimeter of a rectangular field. So one of the first things that we want to make sure we understand is what is perimeter. Let me make my pen. And if you're not familiar with that word, I'll tell you it means the distance around. So if we have a rectangular field, it looks something like this. We're going to have a length and a width, and the perimeter is if you take all of the distance around. So like if you were putting a fence around it, you'd have it around all four sides. So this one across, since it's rectangular, the two sides across from each other are the same length and the two widths are the same. So measuring all the way around, you're going to have length plus width plus length plus width, or we can combine those and say it's 2 times the length plus 2 times the width. So that is the perimeter of a rectangular field. And our problem tells us that the answer to this is 340. So we're given that. Now, this is the second part. The length is 70 yards longer than the width. So we need to define a variable. I'm going to use W as our X. Now you could have done the length as X, but the way this is written, it says the length is, so do you see how that is? The length is 70 longer than the width. So that's 70 plus the width. You see how that just kind of fell into an equation? Length is 70 longer than the width, and we defined the width as X. So now I can go up here to this equation. So I've just focused kind of on taking, this is the English side. I read the words. I thought about what do I know. I needed to think about what does the word perimeter mean, and wrote down the formula for perimeter. Put this into a sentence. The perimeter is 340. I drew a picture, labeled it with my length and my width, and then just took this and took the sentence and just wrote it in the mathematical equation. So even though there's a little bit of math there, I really haven't started working the problem. I've mostly been just interpreting the problem. So this is that English side. So now we're ready to go to the next step, which is flipping it around and taking that circle. We started with English. Now we're going over to math, and we're going to write an equation that uses this variable that we defined. And if you notice, we have a couple different places where we're using the width. It's here, and then it's also over here. So let's just take this equation and rewrite it without the L's and the W's. So 2 times L in terms of x is 70 plus x. So I'm replacing the L with 70 plus x, plus 2 times W is x, equals 340. Okay, so now I have an equation in one variable. This is very close, similar to what we've been working out just as math problems. So we've started with English. We did that conversion into math. Now we're just going to focus on the math. We're going to kind of put the diagram aside, put the formula aside, and just focus on this equation right here and solve it. I'm going to pause the video and do that. You do the same. Pause, work this out until you get down to x equals, and then you can start the video again and see if we're in the same place. Okay, so I have worked through the problem, distributed the 2 across the parentheses. Then I noticed that I had 2 terms on the same side that had x's, so I combined those to 4x. And then to isolate the x, I needed to subtract the 140 and then divide by 4. So I came up with x equals 50. Did you get the same thing? Okay, so we have solved our problem. Now we go back and make sure that we answer the question. The question says to find the dimensions. So we're looking for both length and width. So what did we find? What is x? X is the width. So this is 50. I'm going to put some units on there. It's yards. And then the length is 70 plus x. So that's 70 plus 50, or 120 yards. So hopefully, if we did our problem right, we're going to get this. The smaller of the 2 sides, that is my 50. So let's check. Yay! Don't you love when that green box pops up? Yay! Okay. And the longer, going back to our problem, 70 plus x is 120. Check our answer. Yay. Okay. Okay, I want to do one more problem, and this is number 19. And again, your numbers might look a little bit different. A boat moves at a rate of 13 miles per hour in still water. So if the water is perfectly calm, it's going to go 13 miles per hour. The river's current flows at 5 miles per hour. How long does it take the boat to travel 27 miles upstream? This is real important to notice that it says upstream. That means that it's going against the current. So we're going to be using the motion formula, distance equals rate times time. The rate of the boat, if there wasn't any current, is 13. Since it is going upstream, that is going to slow it down by the rate of the water. So our rate that we're going to be using for this problem is 13 minus 5, which is 8 miles per hour. And we are told we're traveling 27 miles. So now it's just a matter of plugging it into the formula. 27 equals rate is 8 times time. We're solving to find out how long. So we're going to divide by 8. And this problem does say to round to the nearest tenth. So I'm going to take 27 and divide by 8, and I got 3.375. I need to round to the nearest tenth, so that's going to be 3.4. Okay, so I wanted to show you this problem because you might not know what to do with these numbers. When you're talking, sometimes it's going to be the wind blowing or the current. If it's upstream, if they're going opposite directions, you're going to subtract. It's going to slow down whatever it is that's moving. If this was going downstream, it would actually speed it up. And so the speed would have been, or the rate would have been 13 plus 5 instead of minus 5. So it would have been 18 miles per hour.